itself. Okay, so the build times and the test times were going up. It was taking much longer to build it. And to give an idea, when we were using Webpack 4, it used to take around 5 to 8 minutes just to build the dashboard. That itself would have just been fine, but when you combine it with an addition of 8 minutes to run all our tests, and also combine it with the fact that we run all of these CI checks and stuff and build and stuff on every push that we make to GitHub, you'll start understanding what kind of problem it was creating for the CI infrastructure. And at the same time, we had a lot of difficulty in upgrading dependencies. So you have one dependency, the dependency or that package released a new feature that you want to use, but it also came with a breaking change. Now you want to use that feature in one section of your code base, but for that thing, you have to upgrade that dependency everywhere. And if that code base is large, then you have to go around the code base, and whatever breaking change that was, if it is spread across your code base, you'll have to fix it in every place that breaking change like exists. So because of that, we had issues when we wanted to upgrade dependencies. So on top of that, like similar to the previous problem that I told you about, also migrating to a different library. So to give an example, this is obviously an example. Let's say if you were using Redux across your whole dashboard, and you wanted to use something lightweight now. Let's say you wanted to use something like Zushan, which is a more lightweight sort of thing, a more lightweight state management library. To migrate all of your dashboard all at once from one state management library to another state managed library, it would be a gigantic task, and I don't know how long that would actually take. And there was no way to easily increment it. I mean, there are ways, but just to give an example, this sort of works for that. Right. And obviously, when you have a large code base, it takes a lot more time to onboard new developers, because that developer has to navigate across a very large code base. They have to go through more files, because obviously if you see a lot more files on your screen, then you'll also have to worry about those files. So we wanted a way that if you're working on one part of the code base, you don't have to worry about the other parts, and that would automatically reduce the cognitive load that we put on developers. And the biggest problem was lack of independent deployments. So I've discussed 3 products now. Razorpay X's own dashboard. There is a vendor portal for vendors, a chartered accountant portal for chartered accountants, obviously. But all of these apps were still powered by one code base with one Webpack config. So if you wanted to deploy a change to the vendor portal, you make that change in vendor portal. But since you obviously only have one Webpack config and you share one code base, it will build everything, run every test for all those 3 apps. And so a lot of unnecessary and inefficiency there, when you could have just, and obviously it will take much longer if your code base is that much more. So yeah, before this problem started getting out of hand, and we knew that obviously Razorpay X is going to grow a lot more, and we are obviously going to add a lot more code, we decided to sort of do something about it. Before we go any further, let's take one example here. So we have on the left Razorpay X before. We have UI code, and to give you more context, this vendor portal and CA portal and Razorpay X obviously all share the same auth pages. So all the authentication pages and the authentication logic is the same. They share a common global Redux store. We also share basically mostly all of the UI components everywhere. So we wanted to find a way where we'd still be able to share all of this, like share the UI code, share the auth pages, share the store logic between Razorpay X and vendor portal. And at the same time, vendor portal would still be a part of Razorpay X, because Razorpay X obviously has all the logic for navigation as well. So let's say if you go to / vendor portal and you have the requisite permission, you can go to vendor portal. So that navigation and routing stuff is still handled by Razorpay X. So this sort of have to be 2 different code bases, each with their own Webpack config, and more importantly, their own deployment pipelines. But at the same time, they still have to be able to share code and do that very easily, and plus have a really good developer experience. Right. So we started looking for solutions, and on these section change slides, you'll probably find memes, since it's my presentation, and it's also the kind of culture we have at Razorpay. So yeah, we started looking for solutions. Some of the criteria that we were looking for a solution was where, most importantly, it should have a good developer experience. We pay a lot of attention to like not hampering developers, and at the same time solving this problem. Since our code base is large, we don't want to make a drastic change to what we already have, because obviously that entails a lot of effort that has to be undertaken. So we don't want to do that. And we don't want to add additional tools. This is important to us because whenever you add an additional tool, your tool chain is already large. You're adding another tool to an already large existing tool chain, and then someone has to become an owner for this. They have to deep dive and understand and debug every problem that exists with that particular tool. And at the same time, whatever we use, it also has to be relatively easier to configure and relatively easier to migrate to. So these were the criteria that we were looking for. And obviously one given is that there should obviously be the ability to share code between whatever packages we are creating. So the first thing that, like satisfies all the criteria that we thought of was building an NPM library. We could just bundle the UI code and the auth code and the store logic into a NPM library, and we can consume those in both apps, Razorpay X and Vendor Portal. And henceforth, we will refer to Vendor Portal as a separate app on its own, which it actually is. So yeah, this diagram shows NPM library getting installed in both Vendor Portal and Razorpay. So that this was something that we thought of first. So just discussing pros and cons of every approach we thought of. So NPM library obviously makes it easy to version. So if you have a breaking change or if you want to upgrade, you go to the packages on, you bump the version there or just install you're using NPM or yarn, the latest version of your library, and that will obviously give you the latest code. It is also easy to dedupe common dependencies. So an important thing to understand with React is that on the page, there should only be one instance of it. If you have, since React and another libraries also, like React Router and Redux have their own internal state, so you can't have two instances. So they have to be a singleton, and exactly one copy that is used everywhere. So NPM library made that like easy to do, because you could have React as a developer dependency, a dev dependency, or as a peer dependency, and that was pretty simple to do with publishing an NPM library. But there were obviously cons. A lot of refactoring would be required, since you'd have to set up publish flows to publish to NPM. If you on top of that, you would have to set up your own NPM registry, which would be private only and private to your own organization. For that, you would have to set up something like Vadatio or use GitHub packages or whatever would work for you. So yeah, for each app that you created, you would have to set up the publish flow. And on top of that, this was a much bigger problem, was that it slowed down deployments. So if you made any change to the UI code, you'd publish a new version of that NPM library, then you'd go to X and go to Vendor Portal and bump up the versions of UI there. And then you'd have to redeploy Razorpay X and redeploy Vendor Portal. Otherwise, those changes would obviously get reflected with an older version of that library. So, and since we wanted to iterate much faster, and since we go into production multiple times a day, this didn't work for us, because it was painful. And the more micro apps that we had, the more difficult that this would get to manage. And so we started thinking something else, right? So the other option we had was edge side include. Now, not everyone might be aware of what edge side includes are, but it's pretty simple to understand. You have a library project, you build it with Webpack, you just push the, you build and push the bundle that gets created from the library to S3. And then in whatever project you want to use it, you basically import it with a single script statement. Like just add a script, just add a script tag with the URL to whatever bundle that you generated, and it gets added to the page. And this is basically very simple. All you need is an S3 and basically a publicly available S3 bucket. So let's also evaluate this. What are the pros and what are the cons? Pros was that the deployment is very simple. All you obviously have to do is just build it and push it to an S3 bucket. Uh, so talking about the cons, deduping common dependencies between apps is complicated. Now you can only imagine, like I previously said, you only want one copy of React. So you'd have to go into Webpack config and tell Webpack not to bundle React because that would be available in your apps and you don't want to ship it with this library. And you'd have to do it with every shared dependency, and this would get really painful really quickly. Also, this would complicate your versioning because so you basically, if it's available every time the user opens the page and it's just a script tag, versioning is getting difficult because you can't push any breaking change. And so then you have to pay attention to that, since obviously you can't push breaking changes. So you have to adopt some some kind of versioning system where you name the files differently or something. And yeah, the approach is basically crude because you are doing everything yourself. And running tests and sharing types gets more complicated because everything is coming together on runtime, right, and not on compile time. So things like unless you have a monorepo and you have that stuff set up, things like these can get difficult, right? So essentially, the thing I'm talking about is we are looking to build a micro frontend. So why not just use a micro frontend framework? So in that direction, we also took a look at frameworks like Single SPA, Open Components, and Mosaic, out of which Single SPA looked the most promising, mainly because a lot of documentation was already available. There was like a sort of a community help also available for this particular framework. And so also let's evaluate that. Pros is that all of these tools are really opinionated. So you don't have to worry about how to do this thing or how to do that thing, because you'll find everything in their documentation. And as long as you follow that documentation and you don't deviate from the golden path, then you'll be fine. The more common cons are that these frameworks are obviously more complicated. So, and on top of that, you're adding another tool to your existing tool flow. So someone has to own up it. So someone has to take ownership of this tool again. It also requires some kind of expertise in this. You'll require someone who has some kind of expertise in using this thing. And yeah, again, if you're using a micro frontend framework, it's better if you build it that way from the ground up, because if you like try to migrate to it, then it causes a lot of problems and have to do a lot of work. Right. Coming to model federation, as the title already says, this is the thing we chose. But again, I'll go through what model federation is. So model federation is an architectural concept on how to, so what it does is it allows you to share code at runtime. From the diagram, it looks similar to edge side includes. In a way, it sort of is, but a lot of complexity in this case gets managed by Webpack, your bundler. So you are not adding another tool to your toolchain because everything again is getting handled by your bundler. Right. So each piece, each part of your code base can have its own Webpack config. Each part of your code base can have its own, its own deployment pipelines and stuff. So the pro here is it didn't require a large change to the existing code base. The biggest change it required to the code base was that updating imports. We'll come to that later. Another tool is not added because it's a built-in Webpack feature only. So all you have to do is just import one Webpack plugin. Configuration for deduplication is very easy. We'll come to that later. All we have to do is just pass one object to Webpack on what our dependencies are, and Webpack internally manages all of that complexity. Cons is versioning is still complicated. Even with this, we'll explain this in detail later. But in interest of time, let's not discuss it here. Again, test and sharing type will be discussed later. Right. So we have, like I've already told you, we are already using model federation. I won't go too much in depth about what model federation is, because some of you might have already read about it. Some of you will obviously read about it if you haven't already. But I want to share some things that you won't easily find easily available out there. Since the thing I'm discussing here is something that we have implemented already. And so yeah, I have a lot of practical advice to give to you on how to do certain things here. Right. So it's more of a case study. It's something still ongoing. We are working on. It is not completely done. It is only partially done. And I have mostly good things to say about model federation as an architecture pattern, as well as as well as a Webpack feature. So before we go into much further, so let's just have a very brief understanding of how does module federation work. I just told you that it shares code at runtime and blah, 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 a lot of silver bullets, but I haven't actually explained what it is and what it does. So since I told you you can divide your code base into multiple different builds. So let's say you have one folder. In our case, we can have the vendor portal folder have its own Webpack config, right? And each Webpack config and with its surrounding code and its build, you can think of as a container. Container in the sense you can think of a Docker container. And like in Docker, you can expose certain ports. Here in Module Federation, you can expose certain files. Attention to files and not folders. You can only expose certain files from your container. And the way this works is that Webpack will generate a file called remote entry. And this file is pretty simple. Or remote entry.js it's sort of an index or an index table which tells you what all stuff is available to be imported from the container. So just like if when you open a book, you have an index at the start of the book which tells you what all contents are available and on which page they are. This is pretty similar to that. Right, and other containers can use this remote entry file to see what all stuff is available to be imported and basically import stuff from other containers, just like that. Yep, so that was that. To give you an idea about what the architecture will look like with Module Federation, you have the Razorpay X code. The UI code is inside Razorpay X. And the vendor portal code, they can be built independently of each other. For them, they will both generate a remote entry file. For X, we call that file x.remoteentry.js. Similarly, x vendor portal.remoteentry.js. Both the outputs get uploaded to S3. And at runtime in the browser, both the bundles get loaded. Obviously, vendor portal gets lazy loaded and they just work thanks to Webpack. So now getting into the actual implementation details on how we did it. Right. So some more context. Like I said, we lazy load the vendor portal code, and we have this one main component, which is the entry file, like for that dashboard. And we actually use React router. So we have a file called routes.js where we have all of these routes like written in a declarative fashion, which says basically if the path is vendor portal's home, which is /vendor portal, then you render the vendor portal component as long as the user is allowed to see this dashboard. In terms of like context, that is pretty much all you really need. So like I told you, we want to break down our code base into smaller pieces. And we already had a monorepo, which is frontend-x. So we moved the vendor portal code base from X to our monorepo frontend X, since it made much more sense. And later you'll see why monorepo is actually really helps you for building a micro frontend. So yeah, we did that. We took out the vendor portal code from the X dashboard, put it into a monorepo called frontend X. And then all we did was just updated the imports from using, like, this is inside our X code base. We just added X vendor portal and that's it, right? Or that's just wishful thinking. We hope how it works, but obviously it doesn't, because things are not that simple in life. So yeah, the first thing is still updating all the imports. And then you actually need to configure the module federation stuff. So module federation plugin is basically a plugin for Webpack. You can import it from Webpack since it gets shipped built into Webpack. And wherever you are defining all your Webpack plugins, you are just add this much configuration to that plugins array. Let's also discuss what this configuration exactly is. So we previously discussed containers, right? So each container can obviously have its name. We have two containers in our case, X and vendor portal. So accordingly, X's config is basically the name of the container is just X. Name of the entry file that gets generated. This is again the index file that we previously spoke about. So this is the name that you want to generate. This is obviously customizable. So you can follow whatever naming convention you want to. Coming to this, the more interesting things, exposes. What do we want to expose from this container? So we want to expose the UI code. We want to expose some views. We want to expose some API calls. we want to also expose some shared code that we have between two apps. That. And remember, I spoke a lot about how sharing dependencies is a huge problem. So you can do that here. We have this function. It's basically a utility function. We'll also come to that. What that really complicated get shared dependencies function is later. Okay. Okay. So Webpack allows you to basically do everything, generate index file, also what you want to expose, and whatever dependency you want to share. Another thing of interest here is remotes. So remotes is basically whatever containers you want to import stuff from. And it goes something like this. So this is basically the container name, where you want to load this container from. This is actually a variable. We'll come to how this gets set later. And the name of the remote entry file. Right. Similarly, we configured X. Now we are configuring vendor portal. The configuration is again very similar. This is the container name, the name of the remote entry file that gets generated. And in this case, we want to use X as a remote because we want to load some UI code from X and the auth pages and stuff, whatever. Right. And this and vendor portal exposes these three things, which is the entry point for the vendor portal, which is the main component that we put in the React router. And just some Redux related code. We use Redux Saga, so we export the Redux the Saga file from here. And again, the same shared dependencies, which we'll come to later, and we'll also like go into more details on what this is. So with that, basically all the model like model federation config is done. Just do this, and it will allow you to share code between two apps. So, and obviously, if someone is still confused, vendor portal's config. So vendor portal is, since now its own project, it also has its own Webpack config, its own deployment pipelines. So this is the part of the vendor portal's Webpack config, and the previous file was a part of X's Webpack config. Right. So with this, our setup is done. But since if you already know about model federation, you might already know about all of this anywhere. So let's come to the more interesting parts. Developer. So also want to talk about what developer experience is like. There are no memes on this slide because at Razorpay we take developer experience very seriously. Right. So what does development flow look like after you implement model federation architecture? For the developers of X dashboard, nothing really changes as long as they don't go to vendor portal. So if you only run the development server for Razorpay X and you only work with X dashboard, then nothing changes for you, right? Because you don't need any file from vendor portal since you're lazy loading that. So that was fine. And for developers of vendor portal, they have to start development servers of both X and vendor portal because they are exporting stuff from X into vendor portal. So so yeah, they do have to clone both the repos and run npm install. Basically, that's pretty much it, and they can work with vendor portal. Okay, but what about the problem that we initially set out to solve? Like the biggest challenge was having their own pipelines, right? So, but at this point, even that is possible. You can have separate builds, and the deployment tool that we use is Spinnaker. You might use anything else like GitHub Actions or Circle CI or Jenkins, but anything works. So yeah, at this point, both X dashboard and vendor portal have their own Spinnaker pipelines. We wish everything was really nice, but again, let's start discussing the issues. Okay, so the first one we already discussed, sharing dependencies. We only want one version of React, only one version of React Router, only one version of Redux to be present on the page. And you want the instances to be shared across whatever app we come up with, right? And each package basically has to be a singleton. Each package only needs to be downloaded once. We don't want to download any dependency twice because that would consume more network bandwidth, and that is bad. So you remember the very complicated sharing function that I was talking about? This is that complicated function. All it does is that you go to package.json. You require it since require.js or common.js. You get their dependencies object, and for each dependency, you just set two values. You first say that singleton true because you want only one instance of every package, and you set a required version. So required version is sort of self-explanatory, but we want this particular version of the package to be present in our build. And that is like pretty much it really. So it creates an object like this. Say for an example, this is dependency here is React. We want to set singleton true, and we want React to version 17. So that would, so Webpack makes sure that all these conditions are satisfied when it gets loaded in the browser. So one of the major problems is now solved. Right. So running tests. One thing it's even underlined, like I've underlined, is that module federation is a Webpack feature and not a JS feature. So any tool that does not work with Webpack directly is going to have problems. So two of these tools that we rely heavily on, the first one is Jest to run our tests, and the other is TypeScript, which we will again discuss later. So for Jest, so this is an example, right, of what an import looks like after you do module federation. But obviously Jest will cry and it will script that it does not recognize what X underscore vendor underscore portal is. It cannot find it inside node modules. Since it's a runtime thing, Jest is obviously working at compile time. So it's going to crib. So some of the solutions that we initially thought of, the first one was key, like why not just mock the components, like mock every component. But that would be really, really bad. I mean, you can share mocks between any number of packages that you create with for like in a module federated architecture, but that would still be bad because if someone changed that component in the actual code, but you didn't update the mock, all your tests would pass since it's obviously mocked, but it would obviously result in a failure later, and that would happen in production. So we wanted something that would give us that would give the developers a lot more confidence. So we basically cancel out mocking as something that we didn't want to do. The other option was sort of generating a special build to run tests. That also we were not happy with, like the trade-offs that we were making with that. I don't want to go into a lot of detail there since it didn't work out anyway. So what we ended up going with was a configuration option in Jest called module name mapper. If you have set up Jest yourself, you might have seen this. We usually use module name mapper to stub out or like mock stuff like CSS or stuff like CSS or images whenever we are running. Just obviously does not care about resolving images. They don't help you with tests, and even CSS to some extent does not really help with tests. So what you do is basically mock everything out or stub out those resources. But over here, we are not mocking those resources. We are basically just telling Jest where to load those components from. Now, over here, the assumption is that your code is in a monorepo, or you have enforced some kind of directory structure that allows you to do this. So what we do here is we basically tell Jest, we basically tell Jest, whenever someone tries to import something from x/store or x/UI, you basically go, you change this import statement into the X repos path plus to that path where that file already, like that file actually exists. So what the change we are doing here is we are not dependent on mocking. We're actually loading that code from the other code base and running tests on the actual code rather than any kind of mock. So better in terms of resilience because running tests on actual code, and better in terms of giving confidence to developers. So for Jest, this is all the configuration that we really require, other than actually updating imports everywhere to reference this rather than something like this. So yeah, with Jest, that was pretty much it. With TypeScript, it was a lot easier because TypeScript already has this feature called project references, which was built for this exact use case. So TypeScript said since version 3.0, they have this feature which allows you to sort of enforce some kind of logical separation between different folders, and you can build types and do type checking. Like it sort of, you can have build outputs for already existing stuff, and it helps with that. So basically micro frontend, but for type checking. I won't go into a lot of configuration on how this is done, but TS config again looks very similar. We just reference the X folder, and we basically, like we did in Jest, we say here, if it's x/UI, load the types from this particular path. If it's X API, load the types from this particular path. And that's really all that we require. Now, one question you are asking is, this works locally, right? I can just clone two repositories locally and enforce this directory structure, or I can put my code in a monorepo and enforce it that way. But how do we do it on CI? It's it's not very different. Again, the two code bases have to be cloned. Once again, in CI, we use GitHub Actions. So we use GitHub Actions, so we can check out both those code bases. Depending on what tool you use, this might be really easy to do, or probably sort of might be difficult to do. But if you have a monorepo, this is basically not even a problem, because all your code is in one repo itself. So right. Now coming to more issues, that's sort of a developer experience, but you can still mitigate that. Okay, one piece of advice before we move further from here is that when you're running type checking and tests in CI, always do it with the master of the other project. So let's say I'm running tests for a vendor portal. If I'm loading, I need to load the UI code for vendor portal test to work, right? So I will always clone the master branch. This makes sure that you don't forget to accidentally merge your branch in one project and just deploy a breaking change to production. So just a small piece of advice there. Right. A more interesting problem, a lack of HMR. If you are someone who has sort of played around with model federation, one problem you might have noticed is HMR does not work between containers. And for front-end developers, hot model reload is very, very important. Obviously, because we rely on that to give us a very fast feedback. But one thing to note here is HMR does not work only between containers. So if you make a change in X, it gets reflected in X quickly. If you make a change in vendor portal, it obviously gets HMR'd into vendor portal. The only time it doesn't work is if you make a change in X, it does not get reflected into vendor portal. For that use case, you obviously have to rely on live reload, which is again provided by Webpack. So not much of a big deal if depending on your project again. Right. We also spoke about how versioning can get complicated. So let's say you have one app, you want to deploy a breaking change in vendor portal. So you want to deploy a change in vendor portal that will potentially break X. So how do you do versioning? Right, you obviously, since it's a micro frontend, as soon as you deploy it, it becomes available to all your users. So the technique that we have come up with for versioning is it's a naming scheme. You basically use the name of your container here, the remote entry file, and you can add another version here. The version is basically up to you. I do recommend manually updating it I do recommend manually updating this version whenever you need to make a breaking change. But potentially you could also use the version property from your package file if you use something like chainset, or you can use content hashing and check if any of these files are affected and the content hash changes, then this file's name changes. So some of the techniques that you could use for versioning with this as well. But again, the recommendation is to do it manually, as long as you remember that you're actually making a breaking change and it will affect other things. In terms of problems, this is pretty much the last one. We have spoken about a lot of problems here, but I guess it's important when you're running something in production and not just giving a demo of a dummy app. So yeah, how do we assign the URL? So if you paid attention to the model federation config, you would have seen this, right? This is just a variable. It has to be something like a URL and where the remote entry file is present. But you want to do something that works for MVM environment. You don't want to create Webpack config for dev environment. You don't want to have a separate Webpack config for production environment. That was important to us. So we use another plugin called external remotes plugin, which allow it is open source, so you can use it as well, which allows us to put a variable here and define it on the window, anywhere, just using JavaScript. So for us, it looks like this. We serve all federated bundles from a different folder on this. We have a cdn config, which allows us to do this. Whenever something hits this path, you load it from this bucket from the X vendor portal folder. That is for the X vendor portal URL, obviously. So you can configure dynamic URLs based on your different environments like this. In terms of problems, I think I've pretty much discussed all the problems you might face If you have like other problems, you can maybe ask in the chat box later during the Q&A. I might or might not be able to help you with that. So we did all this effort, but now you obviously want to take a look at the results. In the end, it doesn't matter unless the numbers reflect it, obviously. Okay, so sharing some of the results with a small caveat that we are still in the process of going into production with this. It's halfway there, halfway it's not there. So some things might change and some metrics might be a little here and there, but largely they shouldn't. Okay, so reduction in build time. Like I told you before, access time was somewhere between 5 and 8 minutes. With caching in Webpack 5, you can bring it down to 13. But even without caching, vendor portal gets built in like 16 seconds, which is basically 16 seconds is nothing. Local server, it previously used to take a lot of time in order of minutes. Now it takes like starting the local server for vendor portals takes like 10 seconds. Reduction in test times. So previously what we did was obviously when you ran tests for X, it basically ran tests for everything. Vendor portal, chartered accountant portal, X. But with this, if you make a change in vendor portal, you only need to run tests for vendor portal, right? Because since it's a separate repo, you can do it on the CI easily. It's a folder of itself, and that takes even less than 2 minutes now. Independent deployments, this is the one major feature for which we actually started this thing. So it has allowed us to do that. Vendor portal has its own pipeline on Spinnaker. It is completely independent of Razorpay's dashboard. So yeah, it has solved a huge problem for us. And smaller code base, we spoke about cognitive load on developers before. So now vendor portal is its own code base. It is only a limited set of files pertaining only to vendor portal. Vendor portal developers don't have to go to X and touch the files from there. Ease of experimentation, we also discussed this, right? If you want to migrate to a different library or upgrade a dependency version, you only really need to touch the package.json of vendor portal, because Webpack has that required version thing that we discussed. If required, Webpack will automatically fetch a different version of that library if any of the microapps are not compatible with that particular version. With that said, so I have basically told you the results, but we are slightly over time, but some more interesting stuff ahead, some future enhancements. Like, yeah, I couldn't think of really adding any kind of meme here, so the slide has to stay empty. Yeah, so do you remember when I said that vendor portal developers have to start 2 development servers? One was for the Razorpay dashboard, one was for vendor portal. You also don't have to do that, and also don't have to do that, since the remote entry file already exists on, it is already built and deployed somewhere in your Webpack config remote. You can just change the URL and point it to an already existing build. So so once we sort of are in a more stable state, we will work on doing this as well. So yeah, that is the current status, but this is a possibility and it's not very difficult to do either. Right. The other thing is federation for Jest and TS. We already discussed, right, how to run it in locally and in CI. It involves cloning both repositories, which is not a very fun thing to do. Interestingly, I have some news for you here. The author of Model Federation released another plugin called like federated types, which allows you to basically share types with Model Federation. So again, that has solved a huge problem. For tests, I don't think there is an easier way right now, but there is something in the works, like another federation plugin for running tests as well. There is another method that uses streaming, but for most use cases that becomes too complicated, like streaming files. I'm not sure how much effort that is. It's not something we have even looked at yet, but this is a future enhancement. Part of it is in the works. HMR between containers, again, hot model reload. A few developers are going to crave about it, so developers who do need it, but rest assured, this is, I did check myself, this is on the roadmap for Webpack. I have also spoken to the co-creator of Webpack, Zach Jackson. You can also follow him on Twitter, really amazing person. I did ask him about it. He did send me a link that it's there on the publicly visible Webpack version 5 roadmap. So if you want this feature, maybe you can upvote it there. Yep, with that, my presentation is basically over. So thank you a lot for listening to me. If you have any questions, you can ask in the chat and either the YouTube chat or the Zoom chat, and maybe Smile and Siddhant will be able to help me there. Or tag Razorpay's engineering handle with the hashtag Ask Razorpay Frontend Engineers. Yep.
Hey, that was really amazing one. I personally learned a lot of things. There are a couple of questions for you. First one is from Vivek. He asks, how about using an extreme proof build times? How can you cache the build? Also, it only builds affected packages.
Um, Okay, so how you can cache the bills, since it's not a monorepo, so your bills aren't directly dependent on each other. Uh, right, matlab, okay, so okay, I'll explain both parts of this. If you're developing locally, then you obviously need that development server to work locally. So over there is no question of build. You obviously need to run both dev servers on for if you're talking about webpack, if you're talking about caching, that is possible with webpack 5. That you can reduce build times there as well. And on ci, again, I've already explained. In the browser, I'm not sure so in the browser, it obviously doesn't have to do with anything. This is helpful because a problem with monorepos I've seen is they work, a lot of tooling works on compile time. So let's say you want to use the output from one project, you'll have to build that one project, and then only you'll be able to use it. Then only you'll be able to use it in different packages. But modern web federation does not suffer from this, since you can obviously use a already built version and you can load it over a URL or an already deployed version. I hope that answers your question.
Yeah, it pretty much does. I hope Vivek, you got your answer. So next question we have from Mahendra. He writes, first of all, I'm a big fan of your front-end team. My question is that how fresher front-end engineers can land a job without no degree and prior experience. Although we have to build projects, but suppose I am giving an interview in database. So what are the things or the skills you want from a fresher to have?
Okay, that's a wide question. So, okay, so to give you some context, even I joined as a fresher, straight out of college last year in July, if I remember correctly. With degrees, Razorpay does not really care if you have a degree or not. All we really care about is if you have the requisite skills to work here. In terms of projects, it is obviously is really helpful if you already have some projects, but we look for things where you have thought like in depth about the kind of problem you are solving. So if whenever you build something, don't just focus just on the tech. Also think about the end user experience, and and when you do focus on tech, try to think deeply. Try to think of all the approaches that you could have taken, and focus especially on whenever you pick an approach, um, what trade-offs are you making. So like I discussed, right, pros and cons of each method, that is something we look a lot for in engineers, and I think that is a really nice quality to have. And projects to matlab are there if you have some open source projects or like some nice thing or library or whatever project you worked on, it obviously helps.
Yeah. Even just to add, there is one person in our team who did not even have the college degree. He joined Razorpay just after 12th, just because of his skills. The skills are right. We are always open at Razorpay. I have one more question for you from Anil. He said, "Is Razorpay using monorepos?" We have already answered that. If yes, what are the best practices to maintain a monorepo? And are there any framework or tools in the action to maintain them at Razorpay?
Okay, so best practices, I might not be the best person for that, but we do use monorepos, and the tool we use is Lerna. If you don't already know, Lerna is now in maintenance mode. Um, but so depending on your use case, the tools I'd recommend is either Turbo Repo or NX. You might have to take a look at what sort of follow different approaches. So you might have to look at which works for your approach. turbo repo I feel is like more low level configuration. NX will abstract a lot more stuff for you. So just take up whatever approach that works for you.
Thanks. One last question we have. Uh, Rohit writes, "Hey, nice work, great PPT. Can you throw some light on performance part if you have faced any example round trip to load remote entry and subsequent JS files or something else?"
So we have been lucky there since I've already discussed, right, that we used to lazy load a lot of these things anywhere. So you can prefetch bundles. So once your home page is loaded, you can prefetch bundles. As this is something that we already obviously do. Or since we don't do a model federation at a component level, but at sort of a product level, it hasn't really been a performance problem for us. Again, it is still possible to, if you use something like split chunks in your webpack config, it is still possible to effectively bundle so that you only have to fetch one bundle, and that one bundle contains all the shared common code, just using cache groups and the split chunks plugin.
Thank you so much. Sorry, you want to add something?
No.
Cool then. So if people, that's pretty much the questions we have over Zoom and in our question bank and on YouTube. So if you have any more questions, please do tweet it out, ask Razorpay Frontend engineers, and we'll surely get back to your questions. Thank you again so much.
Thank you, folks. Thank you for asking the questions. Thank you for listening patiently. I hope you learned a lot from me. So
yeah, and also Quran tweets a lot of amazing things. Don't forget to follow me on Twitter.
Thank you.
Next we have Prabhas. So Prabhas is one of our lead engineers at Razorpay. He's been with Razorpay for like 3 years, and he have worked on all diverse projects. So Prabhas, over to you.
Yeah, so hi everyone, good evening to all of you. So my talk will be around front-end testing. So yeah, let me share my screen and start. I hope to make this interesting for all of you, okay? All right, so so let me just share my screen. So are you able to see my screen?
Yes.
Okay. Great. So I'm hoping that my voice is also clear. So yeah, I mean, the title of my talk is Meeting Razorpay X Testing OKR. So OKR is like a Google concept around objective and key results. So any engineering practice can be taken as a key, as an objective and a result. So testing became especially for front-end became one of our key and important OKRs since past 2 years to achieve quality. And I am also focused. This talk is around evangelization and visibility and checks and stuff. So we want to show developers exactly what they want to see, right? So let's find out what developers want to see. But let's first go to. So I'll just start with an introduction. My name is Prabhas. I'm also known on the internet as Provoski. I'm one of the lead front-end engineers earlier in the apps team, and now I'm in the front-end infra team at Razorpay X, right? So yeah, and I've been a technology agnostic. So yeah, so before we talk specifically about what engineers want to see, I want to speak a little bit about our journey on Razorpay X, about our front-end testing journey. So yeah, I mean, if I track back to the earliest commits, I think it started about 2018 of November. So we are like about to complete 4 years now. So yeah, I mean, even Burhan pointed this out that it's a large growing front-end code base. There are thousands of hundreds of lines of code. There are features being added every day. I think every one of us in similar companies are having same kind of things. So it has an age of 3 years, 9 months. There is new complexity getting added every day, new features are getting added every day. So that's some backstory here. So yeah, like all good talks, I want to start my talk with a rant, right? We are developers, we want to rant about something. So speaking about testing, I want to rant about Enzyme, right? So earlier on, our testing setup was an Enzyme, right? So the later part of the talk is about visibility, but I just want to just quickly summarize certain things, why we moved away from enzyme. So we want to understand what's brittle, right? So what happens if I take a glass plate and a steel plate and make them fall both on the ground, right? Why am I using words like brittle to describe our test, right? So what's going to happen? I think the glass plate will break and the steel plate will not break, right? So the whole software that we write and tests that we write, right, and this testing code is a similar thing. Like you take some plates and you make them fall on the ground, right? If a test is brittle, if a test is written around implementation, it will break, right? When you the journey of making a thing fall from above is basically code refactorings, right? If something is brittle, if a test is brittle, then it will break. So that's what enzyme was centered around. So I want to talk about shallow rendering and testing implementation details, right? So why are tests brittle? Why are tests written in enzyme not so good? Again, this is just a refresher. I'm sure that a lot of our testing stacks are up to date, but this is just like a small example of what I learned in the journey. So basically, shallow rendering is basically taking the result of the component's render method and just traversing it as a JavaScript object. So let's say you have a component and you have some render, you are returning something from the render and you are setting some state. So you will just assert that, okay, the wrapper state is false or something. So you are also testing implementation details like this. So your tests are centered around how the component has been implemented. And of course, this is a bad practice. If you want to know more about this, you can go over to this blog and understand more about this. So what did we do, right? What did we do? So we listened to our guru, Kenzie Dots, who is a testing guru and a great person on Twitter. So what we did is that we moved away from enzyme to React testing library, because we wanted to write tests like as if we are using test as an actual user. For example, here's a button, right? So this button, how would an actual user see a button or use a button, right? So your test would be like, if I want to see a button whose name is next, and then I want to assert that it's in the document, right? The other test that I can write is that I can take this button and pass it a mock on click, and then I can fire that button click handler, and then I can expect that the mock on click has been called, right? So this is like I'm writing a test like an actual user would use the button, not like okay, that button is clicked and now some internal state has been set to something else, and stuff like that. So that's a bad practice to do. And the other thing is that so this is like refactoring proof test, right? So what we get is that if you write your tests like this, for example, so imagine that, let's just go over a little more complex example than a button, right? So here's a to-do list. So it's waking up, it's making some coffee, it's drinking a coffee and making more coffee, right? So we have a lot of to-do examples across all of front end. So when we use React testing library to write our test, we write something like this. Okay, so wake me up is in the document, right? Let's say we click this checkbox and the checkbox becomes true after false, right? We are not testing any internal implementation details. So just a refresher, I'm sure that everyone is using React testing library, but if you are using shallow rendering and enzyme, it's a great point of time to move ahead to RTL and just make your tests a little bit better. What happens is that if you refactor your test, if you change the name of your state, or if you apply different APIs or change even your front-end stack from Backbone to React, your tests will not break because you are not testing any implementation detail, right? Right. So once we had taken our front-end testing OKR and moved away from enzyme to React testing library, the next step was adoption and evangelization, right? We wanted to ensure that tests have become a part of the development. Whenever a large feature is shipped, we want important and critical flows within that flow to be tested well, right? We wanted developers to take into account that, okay, if it's a job of 5 days, we will at least take 2 days to write tests for out, right? Test on that source code, right? So how did we do that, right? So the first and the existing and the prevalent thing that exists in Jest is coverage threshold, right? So what you do is basically you say, okay, in my Jest config, I say, here's an important module, and I'll basically define what the statement coverage will be, what branches coverage will be, what function coverage will be, and what the lines coverage will be. So what will happen is that whenever anyone will try to contribute to this important module, if they don't meet this coverage threshold across which is split across different things, Jest is going to throw an error, and you will not be able to merge the PR, right? The test job itself will fail with a certain error code, and you will be stuck. Now, I am not a very big fan of coverage threshold because of my journey to other better alternatives. Let's see what the problem is with coverage threshold, right? So let's say we have raised a PR, right? Very, very common thing. We all write features across multiple repos, backend, frontend, and we raise PRs, right? So let's assume that the important module that I just showed here is at 15% coverage, right? And somebody has set the coverage threshold to 40 across all the things, right? And I have written a new feature which is 50% covered, which is in a new folder, and which has just 10 lines of code in the older module, right? So I have touched this module. I have added 10 lines of code in this module, right? And as you can see that it says that, okay, everything should be 40%. So what happens here is that it will throw an error because of course it's at 15% right now. And I added 10 lines to it, and it discovered that it's at 15%. So it's not meeting 40, so it's throwing an error, right? So this error is punishing new developers and new code, right? Any new code that you add to a legacy module, which is at a bad coverage, which should be covered, it will result in an error. So this is some of the errors that it comes. And this is a very common use case, that you have a new folder, new feature, and 90% of your code is in that new folder. And let's say you change 5 or 6 lines or 10 lines in some existing code, which is not very well covered. Okay. So you will basically get this kind of error that important module is not covered because it is required to be at 40, but it is at 14 right now, right? So until I raise the coverage of important module to 40%. So until I meet this 40% coverage of the existing module, I'll not be able to proceed to merge my PR because the testing job will fail, right? So I'm primarily stuck in merging my PR of my new feature until I cover the legacy module. Now, this is not necessarily a bad thing. One of the approaches could be we stand still and we take a job that we write tests and just keep increasing to the coverage till 40 and then merge the PR. That is one of the approaches. Let's try something better. So I was thinking last year, December, right, that can there be a better PR check, or can there be a better way to do adoption of testing, right? So what should I be able to configure differently? So, right. So the current logic is that the global thresholds or the module level thresholds are set to fixed values, right? And anything yet that any change that you do across this will be tested, will be compared to 40%, right? So what could be a new and better way? So let's say that I say all the new files should have X% of coverage threshold, and any existing file that you change should have Y%. Okay. So this is slightly better because let's say I have a PR, I made a new folder, new feature, I have consistent, all those are new files. So I achieve X% across those. X could be like, let's say 40%. And if in a legacy file, I changed like 10 lines of code. So in that file, I can probably raise the coverage to Y%, right? So this is slightly better, right? So we are discovering what could be a better PR check. So we can take it one step further, that if let's say there are in an existing file, there are n lines changed. So 50% of those should be covered, and the overall coverage should be at least 20%. So we should be able to define threshold checks not on the basis of file paths like these, but on the basis of whether they are new, whether they are existing, whether it's if 10 lines are changed in a PR, how much overall threshold do you need, or how many. If let's say you changed in a file, you changed 10 lines, I want 50% coverage. So 5 lines across those should be changed. So this is like a little bit better. So it's very democratic, right? I am responsible for the changes I make in my PR, not the overall code based threshold. So we are not blocking you, but we are ensuring that, okay, if you make, let's say 100 lines of changes in your PR, you have to be responsible for all those 100 lines. There are chances that maybe those 10 of those lines are already covered, right? And if you think about it, it's like TDS, right? Tax deducted at source. Because let's say TDS as a percentage of our CTC, right? So if your CTC is high, you're paying a large TDS. And then we cried about it, of course, about TDS. But similarly, if we have a 10-line change in a PR, we only have to cover those 10 lines because the cost of development is 10 lines. So if I'm able to write tests which are covering those 10 lines, I'm good, right? Instead of being blocked like this. So this I feel is a better way of thinking, a slightly different way of thinking. Right. So what could make it even better, right? So what could be even better if there are already tests that cover those new lines? I don't have to write tests again for them. If there are, because what is testing, right? Testing is basically your test is calling your source code. And let's say you write 10 new lines of source code. And if some existing test is already importing that module and making those 10 lines run, then you are already covered, right? Another point could be that not all your files need to be tested, right? Because let's say you have a constants file, you have a package JSON, right? You have these wildcard files, like you have these basically regular expression which you're describing all your test file or your end-to-end test file or your tailwind config, right? I don't think we need to test those things because those are configurations, right? That we can ignore, right? Another way could be we want to basically skip this check if it's a hotfix, right? So, and just one last thing is that this check should be framework agnostic, because if we are making something and we are thinking, hey, it will only work with React, then it's not really talking for itself. So we have to make sure that if any company is using Backbone or Angular still, and or it's a completely Node.js Express-based project, right? It should still work. If it's somebody is writing WebAssembly, all these things should still work, because we are thinking of PRs as additions and deletions, and we are not concerned with the language or something. We are just concerned that it's front end we are adhering to. So now we have tried to describe all the things that should be in the check. And here's what it looks like. So this is an actual screenshot of us, of me just taking a screenshot of its implementation from a PR. So let's just walk through it, what it is telling me. So it is telling me that this is a markdown table that is telling me something. Okay. So of course the red crosses mean that something is wrong here. So it's telling me that I have created 3 new files here: x.js, y.js, z.js. And out of those, y is disrespecting one of the rules. And you can see for yourself what there are some rules that are getting disrespected. And so basically the mergeability of the PR is at question. So until the PR has the person who has raised the PR has resolved all these specific rules, like in x.js, they have to raise the line-based coverage to 50%. If they might have changed 100 lines in x.js, and they must have only covered 10 of those lines. So I have to actually cover 50 of those lines, right? So it's saying 50% is the expected coverage and 10 is the current coverage. So once all these things are met, only then you can merge the PR. And this is at a change level. So the main point I'm deriving is this is at change level, not at the global file level. And yeah, that to me is a bit better. So let's see it in implementation, right? So I don't want to deep dive too much into implementation. I'll try to go a little bit deep. Again, this will work for all kinds of CI/CD, Jenkins. We are using GitHub Actions. If you are doing something else, it will work for you. So the primary thing that we are using here is Danger.js, right? So I just go to Danger config once. So Danger is if you don't know what Danger is a great, multi-platform, multi-language based CI check, which can help you automate redundant tasks, right? So we are using Danger.js. We are of course using Jest as our test runner, and we are using GitHub Actions, right? So the GitHub Actions can be, I think, interchanged with some other CI/CD as well. Danger.js is available across multiple. It's available across GitLab. It's available across multiple other Jenkins and stuff. So let's see it working, right? So why do we use Danger.js? So the production of this table, right? What we did here is a redundant task. We want this to happen automatically on every PR. We don't want to somebody goes and comments on the PR, right? So let's just study the timeline of Danger.js. So basically somebody pushes code. Some of the linters and tests are run. Tests are run on CI. Once those tests are run, the coverage is produced at the CI level. So the coverage that we want is produced, and then that coverage is consumed by Danger.js. So yeah, I hope this slide is making it clear. You can find out more on dangerjs.org, I think. Danger.js.org, right? And the other part of this is a cobertura, right? So what is cobertura? Okay, so Jest is able to produce code coverage. So the first thing we need for this check is code coverage, right? We need code coverage of the entire source code that in a PR that the person has raised, right? Why cobertura? Okay, I want to show you something here. Jest or any test runner. I think a lot of newer test runners are available right now, like PyTest. But Jest is a very old age and very battle tested test runner. So it runs your test, whether you are in Enzyme, you're written E2E test or other kind of test. So it is able to produce code coverage for you, right? If you observe my screen, what I'm able to see here is that it is able to tell me, okay, I have gone over all your code base and I've been able to run all the tests. Here is a source code file that I have tested, and this is the result that I got. So all the lines that are running with green have been called, so they are part of the coverage. And this particular line was not called in a test. So this is a line that was missed, right? So that's what the coverage is. And the good part about this is that Jest is able to use code coverage in multiple formats. It is able to produce it in the LCOF format that we just saw here. So this is the visual LCOF format, which is like a graphical HTML format. But of course, this is just for a graphical user interface. It is not it's not consumable in a test, right? So cobertura is another format of producing code coverage, which you can configure in Jest by just mentioning, that I want the coverage to be in cobertura. And what it gives me is this XML kind of format, right? So let's just study what the XML is. So basically, it tells me that, okay, this is a folder. This is a folder, and then these are the different files inside that folder. So a package is a folder, then a class is a file inside that folder. Here are the different methods inside this file. Here are the different lines inside that file. And for every line, if you see, there's a thing called hits, right? Hits means that it has been called 7 times by a test, right? So the line itself is being called. So it's a hit, right? So it's covered by a test, so it's not missed. So those are the different things. There may be certain lines which have a hits of 0, right? So those lines have not been called. So those are the lines that we need to write a test for, right? So what we do is we just basically take this XML. So it's the main thing is that it's in a consumable format. Like if I run my test, I produce my coverage, I get this XML, I'm able to convert this to JSON and then do some operations with it on Danger.js. This was the main center point of the entire check. So let's talk about the actual calculation, right? So what could the calculation be, right? If I go back to this table, what is it telling me? It's telling me that in x.js there's a certain expectation of a coverage, and here's the actual reality of a coverage, right? If it's meeting or not, and if it is not meeting, then it's like driving me. So it's basically, it's very, very if you remember like the maths we studied, it's like a Venn diagram, right? There are the covered files which this cobertura coverage gives me. There are the changed lines in a PR, right? So if you go over the Danger.js documentation right here, right? So you'll get a lot of options here to see what are the changed files, what are the files that change, what is the PR number, what are the PR labels. So all those things that we need for our calculation is available to us, right? So right, the change file is available to us and the covered files are available to us. So right, so in the center are the files that we changed that are covered by test, but this part on the right which is remaining is the files that were missed, right? That's what we want. So so if we try to, this is a simplified view of the calculation. If we try to just try to see the calculation in a little bit in a more of a diagram in a flowchart way, imagine that these are the file changes, right? So there are the different lines that got changed: L1, L2, L3, L4, L5, L6, and there is a coverage report, which is the cobertura report, which tells me, okay, which is what line is covered, what line is not covered. So if we do a simple comparison between the two, I know that, okay, there are 4 lines which changed, and there are just 2 lines out of those 4 which are covered. So there are 2 lines which are not covered, right? So it's very simple mathematics once you know about cobertura. And so the overall coverage is 50%, and you can add a check here. It's a dialogue decision thing that, okay, is it passing or is it not passing? So yeah, so that's the whole flow chart for this check. It's a very simple addition subtraction mathematical program. The main piece is cobertura. So yeah, so there is a prerequisite to running this check. What is the prerequisite? The only prerequisite that we want is that when you are running, well, let's say you have any a code base in any language, right? Your test runner should be able to produce the test coverage in cobertura format, because that's the main anchor point around which this whole test runs, right? So so yeah, if you are using Jest, it's very simple. If you are using ytest, I'm pretty sure that it will also produce it in cobertura. If you are using C++, and if you have a local runner that gives you cobertura coverage, you can still write a danger.js for it. So it's very language agnostic. Okay, so the impact that we have seen with this check is that our code coverage numbers have drastically improved, because now the writing of tests are an organic part of PRs of any feature development, without which we are not sort of allowing them to move forward unless it's a hot fix. It's a very bad production hot fix. So yeah, that helps us. And it's also based around the change. So people are happy to see if people have changed 10 lines, they are okay. We'll write the test for these 10 lines. They are happy. Let me talk about the usage a little bit. So in the earlier talks in Frontend, we have talked about Frontend Universe. So the current state of this check is that we have released this internally in Razorpay in Frontend Universe to see its effectiveness, to battle test it out a little bit. We will be open sourcing this check in some time, once we are very ready. So let's just try to see the API that we are using across this check. So let's just concentrate on the second pair of parentheses here. We are saying exclude patterns. Okay, so we are saying don't include these files in the check, because of course you don't want to include tests when you are running this check. You don't want to run this check for tests, because right. And then we are saying include these files. We want to include the JavaScript files, the TypeScript files inside SRC. So whenever there is a miss across these files, we want some shouting on the PR, right? What is a skip label? A skip label is basically that, let's say some production P0 action has happened and you want to quickly merge code. If the PR has a label of skip test, then we will let you merge without this test running, so that because what's more important than a P0 production issue, right? And then this object right here is also really important. We are saying coverage restrictions. This helps us calculate this warning. So I had showed you the warning, right? This warning right here. So the warning expected and actual. So expected, whatever is expected out of a file, we specify this warning right here. So we are saying for all new files, the lines that have to be, there should be a 50% code coverage. There should be an overall 50% code coverage for all new files. And we are saying that for existing files, 80% of those lines should be covered. So if you are changing 100 lines in an existing file, 80% of them should be covered, and the overall file coverage should be 30%. So this is the main driver that drives the whole check. We are saying that if this check fails, then simply put a warning on the PR. We can change this to failure if you are pushing for a more aggressively thing. And lastly, we are saying that, okay, whenever I'm running my code coverage check on CI, here's the part to my coverage XML, which will be used in the CI, right? Okay, so I want to demo something for you. So this check was ready in the first half of this year. Then we were thinking to ourselves, what can we do more, right? So one of the more important problems to me was that, let's say I give some feedback on a PR, right? Like this is an actual PR. This is a very generic PR that I had raised. What could be one step ahead for this PR, right? So one thing for me was that, okay, you have told me that the expected coverage is 80% and the actual coverage is 40%. Now, which lines should I write tests for? Like, how do I know which lines of 80% and which lines of 40% should I? So where should I write my additional 40% of those checks, right? So I was thinking about writing a Chrome plugin that can interact with Danger and interact with the lcov file to give something like this. But then I thought that, wait a second, we already have a difference view in a PR, right? So what we did was that we hyperlink these links to a PR. So when I click on this, see where it goes to. So it automatically goes to access.deny.js, right? So it went to access.deny.js, and I'm able to see, okay, these are the different components that are maybe missed to me. So I'll basically write a test for some function. So that was solving the visibility problem for us, right? So this was a recent thing. So if I command click on utils 1, 2, 3, right, it navigates to utils 1, 2, 3, right? It automatically navigates it, right? So this was a very thing around visibility. So why we did it was because we wanted to show developers, okay, this is the line that you are missing. This is the line that you have to write test for, right? If I backtrack the solution, how are we doing it? So all these, if you study this URL, right, all these URLs are basically is of the type. So here's the base PR link, which is available to us via Danger.js. And here is this really weird looking, something like a git commit SHA, right? So when I figured it out, I thought that, okay, this can be one of the SHA. So it turned out that it's basically taking the file name and it's applying SHA 256 encryption over it. And that is how the URL is getting constructed. So that's what we did, so that the file itself could point to the link of the difference, so that developers don't have to see, okay, how do I go to 40%? What is the thing that is missed? What are the lines that is missed, right? So that was one addition that we did to the check. So what's next? I will be releasing an example of this on Twitter very soon. So you can follow me. You can follow Razorpay Frontend Engineering. So it will be like a whole working example. There will be some code in a different languages, and we'll try to get it up. So it's just a matter of porting some code. Also, I think Frontend Universe will be, I don't know if they will be doing open source very soon, but it's already part of Frontend Universe. But yeah, I mean, follow us on Razorpay Frontend Engineering, where we'll be releasing a code example of this. You can integrate it in your CI. If you are using a different kind of CI, if you're using Jenkins or if you're using GitLab, you just need to change the danger-based danger functions, which will point to the new CI, and the rest of the mathematics will work pretty much the same. And then you will start seeing warning like this in your PRs. And hopefully these warnings will give developers a sense of enthusiasm and a sort of like a true actual picture of what we can do to make testing a good goal again. So thank you. I mean, I did not go too deep into the code of it, but yeah, I mean, a very cohesive example will be getting released on Twitter very soon. Please follow Razorpay Frontend Engineering on Twitter. We'll be releasing this example. We'll be getting posted. We'll also tag it with the handles. If you have any examples, if you have any questions, you can type them in the chat. And please do follow Razorpay Engineering. And also, you can also follow me on Twitter. I'm called Prabhuski.
Hey, Prabhas, thank you so much for such insightful insights you shared with us. There are a lot of questions for you. I'll take a few of them.
Okay.
So the first question is, Syed asks how to learn problem solving as a front-end engineer.
Okay. So problem solving as a front-end engineer. So problem solving, I think first thing is that you should not be, don't try to first say it's a front-end problem or a back-end problem. Problem solving should not, at the initial start of the process where you're trying to analyze the problem, don't try to bound it to a certain technology or bound it to a certain paradigm or something. Think about it freely. Try to see what data you have, try to see what data you want to go to. Making smaller sets of the problem, changing it to smaller sub problems always helps me out. Like, try to find the first milestone or first sub problem that you want to solve. Try to get to that point. Like, if you want to make a 3D chess game, right? So you can say, okay, my first point is to show a chess piece and show the 12 pieces, and then probably do a 3D emulation later on. So yeah, try to get intelligent sub problems and checkpoints intelligently and try your way from there. And of course, you have to be very aware that there are multiple paths to solving the same problem, and accepting that there may be a better solution. Always be, don't be afraid to delete your own code. That's one thing for sure. And don't be afraid of change. Yeah.
Very nicely quoted. We have one more question from Harsh.
Yeah.
He asks if the overall coverage is not above the some threshold, do the test should fail?
The test job fails. For example, if you use the threshold, that threshold object, right? You can even specify global inside it, and some certain other folders that if we want these folders, that also works. But this method also works. The testing job does fail. Just try to have a simple repo, set up a really high threshold object like 100% for all the things, and then don't supply tests for in a repo, and then try running that job, and it will probably fail. So if it fails on a PR level, then you are blocked. There can be various error levels. You can choose to ignore it, but yeah, I mean, it's better to the threshold based strategy does work if you are just starting out. I'm not saying that's a bad strategy. That's a very nice strategy by Jest, and it's a hand picked strategy. You don't have to worry too much about APIs, but yeah.
Okay. There is one more question on same lines.
Okay.
Typically, how often or how much does a front-end developer test their code? Or are there any separate test teams to test it? How much of testing knowledge is good for a FE developer?
Yeah. So I think once you start thinking of testing as part of your development, your evolution as a front-end engineer would be go on to the next level. I mean, I have seen, even I have been a part of why are tests necessary bandwagon. But as I started thinking about testing and why they are so important, because if you think about it, if a feature goes and your feature breaks, that's simply because you did not write tests for it. If you have written tests for it, it would be detected early on at the PR level. So the bang that I get out of writing some test, so that my feature is protected by other, or like always think of how your code will be when others try to refactor it. If they refactor it and something breaks and they don't know, and it goes to production, right? So that's a major thing. So I think that tests are necessary. If you are doing a hackathon project, tests are not necessary. If you're doing like a 2-day hackathon project and you're building a simulator, maybe some testing Nazis would say that even then they are necessary. Yes, I mean, it would take it to the next level. TypeScript is necessary. If you are working on a professional level, large code base enterprise application, tests are absolute necessary, and embracing them early on, and even if it comes at some friction and loss of development speed, it will be like a very large long-term gain that you get out of it. And as to what technologies you should use, I mean, the Twitter and there are full of blogs, like try to follow Kenzie Dodds and a lot of good. The testing world is very opinionated. There were a lot of technologies that were kept changing in the past, but now I think we have settled down on what we should use for E2E, what we should use for integration testing, what we should use for our test runners. So it's a very mature stack that has already been chosen by the top 10 Fortune 500 companies, top 5. So and majority of the startups. So yeah, I mean, it's very easy to take that same direction and just start working with the API, start understanding what means. And once you get the hang of it, I think it's a very no-brainer thing if we just start learning it.
Yes, very true. On similar lines, again, I have one more question. So how far do you look into future while selecting a technology or a framework?
If I look at a technology, I mean, when I'm choosing a technology, I try to make a point to at least try 2 or 3 similar technologies. I don't make a point of this is the best technology, and I will not look beyond it. If a technology has been, it's all about adoption, right? Why do we like React, right? There are all these new frameworks coming up that are saying that we are 1/10 the speed, or even with bundlers and stuff. But one important point is that how good the ecosystem is, how mature the technology is. But that is one important thing for me, and that also translates to GitHub stars and the amount of community is there a Discord community or not. all those stuff is there. Like I wouldn't choose especially when working with a production or a enterprise application, it's always better to choose like a slightly mature technology than a newer technology. And of course, there is no harm in trying out newer advanced WebSockets and absolute crazy stuff for your think projects, and slowly bring it to the production curve.
That was really cool tip for everyone.
Yeah.
I'll just ask you one or two light questions. It feels like I've bombarded with you some heavy questions. So, what is the most interesting thing or interesting project you have worked on?
I mean, if I don't say this project, then I would be lying. I like this project. It started. This is one of the interesting projects that I worked with. I'm also currently working on front-end observability, that detecting P0 issues early on via real-time events analysis. So I don't know if it's going to amount to a very big thing, but it's interesting. Like I'm working mostly with SQL for the past 2-3 weeks, so that's very interesting. Yeah, I mean, most interesting. I mean, I can't really say. Like if you ask Tanmay Bhatt what is his most interesting joke, it's become a pile of work. It's like I think building Razorpay X through the initial days, working with the developers, forming the team, and working with the lead engineering here has been amazing. Not all great work has to be tech work. It can be like a little bit of people work as well.
True.
Yeah.
That's really, really true. So, just last again, one more fun question. So, since you are in this industry from a long time, what is your favorite hook you have ever written? Like, hooks are these days become very essential part of React ecosystem.
Probably uh, a use query clone. I think we are no sorry, a use mutation or use query clone. We are trying to write that. It's pretty fun. Trying to call post APIs from a button click. I think that one. We take a really React queries. We are trying to hack into React queries, see if we can build it for ourselves. That sort of stuff.
Nice. That's pretty much questions the audience had for you.
Okay.
If people you have any more questions for Prabhat or Paran, do check it or do tweet it out on tagging our Razorpay engineering, and we'll for surely reach you out. And also these two people tweets a lot of amazing content on Twitter. So do follow Prabhat and Paran on it. Before we wind it up, I have a couple of announcements. I'll quickly share my screen. One second. Yeah, again, one more time, thank you, Prabhas and Buran, for taking time out of your busy schedule and giving us some amazing insights from the things you build at Razorpay.
Thank you.
So I have a couple of announcements. I hope people are still excited after listening. I know my announcements may not be that exciting as the work done by Prabhas and Buran, but let's see. So as you have seen, no Razorpay is incomplete without memes. So today after this meetup, we are hosting a meme competition. We'll post its details on our Twitter handle. Do participate in the contest, and yes, you will win amazing goodies, just like we have given some amazing goodies in React de Bangalore. If you have seen, I saw a lot of buzz on Twitter about that. So don't forget to check it out. Our Twitter handle after the meetup. Then next, yes, we are planning to host these meetups every month. So if you want to get updated on whatever meetup we are planning next, do follow our Razorpay Engineering Twitter handle. We not only we post about meetups, but we also post about some tips up on dev productivity, some day-to-day things, and some fun things. And yes, for getting updated on videos, and we are planning to post more regularly on our Razorpay Engineering channel. Some fun things about frontend, some fun things about backend, some fun things about DevOps, some fun things in general about all the domains. Do follow us on YouTube also. So yeah, that's pretty much about me. So let's see you soon in the next meetup. Thank you all for joining. Have a great day.